Hey everybody, so in this section we're going to quickly review what is an intercept and how do you find it algebraically, okay, and then how do you use it to graph. All of those topics should be reviewed, and then we'll focus on some more advanced topics about using intercepts in word problems. Okay, so first of all, an intercept is a point where a graph crosses an axis. Okay, so specifically, an X-intercept is where a graph crosses the x-axis. Okay. And a y-intercept is where a graph crosses the y-axis. Okay. All right. So the first thing we're going to do is do a couple computational examples of finding the intercepts. Okay. Okay. So I guess this is part A. So we're going to use the equation 2x plus 6y equals 12. Okay, so for part A, we're going to find the intercepts. Okay, so I will remind you that for the x-intercept, okay, I'm going to set the y value equal to 0. Okay, so this would be 2x equals 12, so x equals 6. Okay, and you are going to give your value as an ordered pair, right, where the x value is 6 and the y value is 0. Now the reason that's so important is because an intercept is a point on a graph, so you want to give a corresponding thing here. Now the only piece of this that you would be able to leave out is this, okay? The other steps are 100% necessary. Here you're showing me that you understand how to find an intercept. Here you're showing me the correct answer. And here you're showing me that you understand it's a point, right? So because you're showing different things in each step, you really need to show all three things. Okay, let's find the y-intercept here. So for the y-intercept, you would have the x value is 0. So you get y equals 2. Okay, and again, we're going to list this as an ordered pair. X is 0, y is 2. Okay, and again, there's only one step that you can leave out, and it's this step here in the midst of solving. Okay. All right, so I hope that refreshes your memory. So let's look at part B for this, which is to graph using the intercepts. Okay, so let's look at a graph. All right, so unlike the word problems, we're not restricted by anything, so we're going to show all potential parts of the graph like this. Okay, and then we're just going to graph our two intercepts, which were 6, 0. 1, 2, 3, 4, 5. So this is 6, 0. Okay, and then the point 0, 2, which would be there. Okay, now you know this is a line, so you would connect these with a line. Okay, All right. Let's do another example of that. Okay, I want to do a more unusual example so that you guys are comfortable with these. Okay, that doesn't look how you would normally see the equation for a line, okay, but this is okay. And so for part A, we're going to find the intercepts. Okay. All right. So the first thing we're going to do for the X-intercept is we're going to let y equal 0. Okay. Again, I'm showing myself plugging in y equals 0. Okay. 0 over 4 is 0. So I just get x over 9 equals 1. Okay. Now you can just multiply both sides of this by 9 to get rid of this denominator. Okay. So if you do that, right, these will cancel and you'll get x, and over here 1 times 9 is 9. Okay, and again, you're not going to forget to write this as an ordered pair. The x value is 9, the y value is 0. Okay, now we'll do the same thing for the y-intercept. Okay, so we're going to let the x value be 0. Okay, so this is 0. So we'll get negative y over 4 equals 1. Okay, and then I'm going to multiply both sides by 4. So I'll get negative y equals 4, which gives me y equals negative 4. Okay, and I'm going to write this as an ordered pair, negative 4. Okay, now if you're the kind of student who wants to show the absolute bare minimum, okay, you could leave out this step potentially. Okay, and same thing over here, you could leave out this step and even this one. Okay, I'm only saying that because students are always asking me, what can I leave out? What can I leave out? The more work you show, the better. But if you're desperate to leave out steps, those are the only ones that you are allowed to leave out. Okay, so for part B here, it's going to say graph using the intercepts. Okay, so what we're going to do again is draw our graph so that we can see all 4 quadrants here. Okay, and then we're going to graph our 2 points. So we had 9, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to extend this. Okay, so this would be 9, 0. Okay, and then our second point was 0, negative 4. 4, 5. Okay, so this is 0, negative 4. Okay, and again, I know it's a line, so I'm going to connect my 2 points with a line. Okay. All right. So that's a little review of how to find the intercepts from an equation and then how to graph using the intercepts, or using the intercept method, it's sometimes called. Okay. All right. Now that we've reviewed that, let's move on to some word problems. Okay. An owner of a gas station has $4,800 to spend on gas this month. Regular costs 60 cents per gallon and premium costs 80 cents per gallon. Okay, so how much would 1 gallon of regular cost? What about 5 gallons? Okay, so 1 gallon of regular, you can see it's 60 cents per gallon. So 1 gallon would be 60 cents. Okay, then what about 5 gallons? Okay, so I want you to decide what the answer to this would be. Okay, and then also I would like you to think about how you got that answer, because this question is leading up to an equation. Okay, so 5 gallons, we would have 60 cents, okay, a gallon, and 5 gallons. Okay, so hopefully you got that this was $3. Okay, now let's think about how we got that so that we can answer part B, write an expression for the cost of X gallons of regular. Okay, so we're going to think about how we got this 5 gallons. We took the number of gallons, okay, which now is X, and we multiplied it by 60 cents. So I'm going to take X and I'm going to multiply it by 60 cents, which is 0.6. Okay, so again, we're using this numerical example and what we did to get the $3 to tell us how to write this expression. Okay, again, expression, no equal sign, just the right side of the equation. Okay, all right. Part C, how much would 1 gallon of premium cost? Well, 1 gallon of premium we know is 80 cents. Okay, what about 5 gallons? Okay, so again, I think you guys know how to do this, and hopefully you got that this is $4. Okay, we're going to use that to answer part D. Write an expression for the cost of Y gallons of premium. Okay, so if we think about how we got this $4, we took the number of gallons, which was 5 in this example, but now it's Y. Okay, and we multiplied it by that 0.8. So I'm going to take my Y and I'm going to multiply it by 0.8. Okay, all right. So part E, which is the main part, write an equation that relates the gallons of each type of gas purchased and the budget. Okay, so first of all, we know that the total cost, okay, is going to be the price of regular plus the price of premium. Okay, if you're not sure where to get started, I think that sketching something out like this with the words in it can help you fill in the quantities. Okay, so now we're going to look back in the question and see what the total cost was. So the total amount that we were allowed is $4,800. Okay, now what were we spending on regular? Well, we were spending 0.6 X on regular, right? For X gallons of regular. And then for premium, we were spending 0.8 Y, right? This is the cost of X gallons of regular gas. This is the cost of Y gallons of premium gas, okay? And what we're not going to forget to do is name our variables here, okay? So X is the number of gallons of regular, okay? And Y is the number of gallons of premium. Okay, it is very important to tell me what your variables stand for, even though we kind of saw that in part B and D where it asks us about X and Y. Okay, we're going to make sure. Okay, so this is part of our answer and the equation is part of our answer. All right. So this is something that we could have seen in 1.1 or even in 8.3, but let's look at the part that's specific to this section. Find the intercepts. What do they mean? Okay, so we're going to find them the same way that we did in the previous example. Okay, so for the X-intercept, we're going to let Y be 0. Okay, so this would give us, okay, and then we would divide by 0.6. To get 8,000. Okay, and we're still going to write this as an ordered pair, even though we're talking about a word problem. Okay, the intercept is always an ordered pair. Okay, and then we'll do the same for the y-intercept. Okay, we'll let x be 0. Okay, so this is 0. And we would divide both sides by 0.8 to get 6,000. Okay, and we're going to write that as an ordered pair, 0, 6,000. Okay. All right, so that only answers the first part, which is find the intercepts. Okay, so we still need to answer what do they mean. Okay, so whenever something's asking about a word problem, what does this mean? It's asking you to interpret it in terms of the words from the word problem, right? So about gas and cost, what do these points mean? Okay, all right, so we're just going to go down here. We're going to wait on this. Okay, so we will graph using the intercepts, but first we're going to write down what these mean. So you're going to explain both parts, right? What does x equals 8,000 mean? And then what does y equals 0 mean? Okay, so the x equaling 8,000, remember x is the amount of regular gas bought. So if they buy no, right, 0 gallons of premium, so if they buy no premium, they can afford 8,000 gallons of regular. Okay, that explains this, right? The 0 means how many gallons of premium there are, so there's no gallons of premium, then they're allowed 8,000 gallons of regular. Okay, so we're going to talk really similarly about this. The 0 is how many gallons of regular, so we would say if they buy no regular, they can afford 6,000 gallons of premium. Okay. All right, and the last thing we're going to do is graph using the intercepts. Okay, we are going to do that. So we'll grab some graph paper here. Okay, so again, we're not going to have negative gallons of gas, so we really only need to focus on the first quadrant where both things are positive. Okay, now remember x is regular, y is premium, so we're going to only have to go up to 8,000 here, so 1, 2, 3, 4. So we have plenty of lines, right? So I'm just going to go by 1,000s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5. Same thing for y. 6, 7, 8, 9, 10. Okay, and then I'm just going to graph my 2 points. So the first point was 8,000, 0, so that's going to go here. And my second point was 0, 6,000, so that's going to go here. Okay, and just like any graph, I'm going to connect my 2 points with a line. Okay, so the method for graphing is the same, right? You just draw the 2 intercepts and then connect them with a line. Okay, let's do one more word problem example. Okay, a deep sea diver is tracking readings at a depth of 400 feet. He begins ascending, right, going up towards the surface at 20 feet per minute. Let m be the time in minutes since he started going up, right, started ascending, and let d of m be his depth. Okay, so again, we're talking about function notation here, where the input is his time in minutes going up towards the surface, and then d is going to be his depth. Okay, so the first thing I'm going to ask you to do is just fill out the table. So go ahead, pause the video, fill this out now, and you can check your answers with me in a second. Okay. All right, so after 0 minutes, that means he hasn't started going up yet. So his depth is 400 feet. Okay. Now, after he's been going up for 5 minutes, right? Remember, every single minute he's going up 20 feet. So that means after he's been going up for 5 minutes, he should have, right, gone up 100 feet, which would put him at 300 feet. Okay. After 10 minutes, he's gone up 200 feet, which put him at 200. After 15 minutes, he's gone up 300 feet, which would put him at 100. And after 20 minutes, he's gone up 400 feet, which would put his depth at 0. Okay. All right. So let's look at part B, which is graph using 3 of your points. Okay. So here it specifically tells you to use 3 points. Otherwise, we know that 2 points determine a line. Okay. So let's go ahead and graph using 3 of our points. Now, we're going to choose which points here. Okay. I'm just going to choose the first 3. Okay. So 0, 5, 10. Okay. All right. So let's look at my graph. Again, I don't need negative time, and you can't have his depth be negative either, right? Because that would mean he's way above the surface of the water. Okay, so I'm going to go here because the minutes seem to be going by 5s. I'm just going to go by 5 minutes here. So 5, 10, 15, 20. Okay, given the space that we have here, you probably could go by 1s, but all the ones that we have on the table are by 5s, so this also works. Okay, and then here I need to go all the way up to 400, so okay, so I have 14 lines. I'm going to take 400 and divide it by 14. Okay, and I get 28. So I could go by anything bigger than 28. Okay, I'm actually going to go by 50s. Okay, so 50, 100, 150, 200, 250, 300, 350, 400. Okay. And now I'm going to mark all my points. So 0, 400, 5, 300, okay, and then 10, 200. Okay. So you can see that these are making a line, and we're going to continue our line like that. All right. So that was part B. Part C, when will a diver be less than 200 feet below the surface? Okay. Now, we can actually see this from here. Okay. So you can see that at 10 minutes, he's 200 feet below the surface, and after that, he's closer to the surface. Okay. You could also see it from the graph. Okay, so here's where you hit 200. Okay, and you can see that that's after 10 minutes. And after that, his depth is less than 200. Okay, so when will his depth be less than 200 feet? We would say after 10 minutes. Okay. All right, so now we've answered all these questions without actually having an equation. So we're going to write an equation for D as a function of M. Okay. All right. So we're going to think about what we did to get the answers in the table. Okay. So we took the number of minutes, okay, which now is going to be M. Oh, first of all, we're writing an equation for D as a function of M. So we're going to start with D of M equals 2. Okay. Now we're writing we took our value m, the number of minutes, right? And we multiplied it by 20. So I'm going to take m and I'm going to multiply it by 20. Okay, and then we subtracted our answer from 400. So I'm going to subtract this from 400. Okay, so again, we're using the process that we use to get the numerical answers for the table, and we're just writing that out symbolically, right? So we took the number of minutes and multiplied it by 20 to see how far up the diver had gone, and then we subtracted our answer from their original depth of 400 feet. Okay. All right. So we're going to find the intercepts, and then we're going to say what they mean. Okay. So the first thing I'm going to do, okay, there's no x here, but m is the x-type variable, so this is going to be the m-intercept. Okay. And remember, when you have the x-intercept, you're letting y equal 0. So from my equation here, here's my y component. I'm going to let that equal 0. Okay. Just add 20m to both sides, and then divide both sides by 20. Okay. So this would give me my point 20, 0. Okay. Remember, when you're writing an ordered pair, which is the x-type variable and which is the y-type variable. Okay, so remember the input variable is x-type, it goes first. The output variable goes second. Okay, then I'm going to find the D-intercept, okay, which is the other one. And here I'm going to let m be 0. Okay, now this is very important. I want to point this out. When you're plugging in m equals 0, you also need to do that into the function notation. So if we're plugging in 0 here, we also need to show that we're plugging in 0 here. So I'm going to do that. Okay, so it's very important that when you're plugging in a number, you're reflecting that in your function notation. Okay. Now 20 times 0 is 0. Okay, so this is going to give me the point 0, 400. Okay. All right. So I just wanted to point out again about the notation. You have to be careful when you're plugging in 0. When you're plugging in y equals 0, this whole side becomes 0, right? Like you can see here. When you're plugging in 0 for m, you plug it in here, but you also plug it in here, and that's why you can see it here and here. Okay. And even though we're talking about a word problem, we're not going to forget to write here and here our problem as a ordered pair. Okay, so what do the intercepts mean? Remember, we're going to explain both parts. So m is the minutes, so we would say after 20 minutes. Okay, and then we have to say, what does it mean that his depth is 0? Okay, so to me, that means the diver is 0 feet below the surface, so that means they are at the surface. Okay, we want to use as much plain language in these what does it mean as possible, right? We don't want to say they're 0 feet below the surface. You would just say they're at the surface level. Okay, and again here, we would say after 0 minutes. Well, how else can you say after 0 minutes? So you might say to start, okay, the diver, and then remember the 400 is the depth, is at a depth of 400 feet, okay? So I encourage you to practice this about translating what those zeros mean in terms of mathematical language into something that's much more understandable, like to start, or he's at the surface, instead of saying he's 0 feet below the surface or after 0 minutes, right? We really want to interpret what those things mean, okay? You guys will see more practice with homework, and I'll see you guys soon.